14 goes with C. So 10B, 12F, 14C. You guys had to use clues like who's squared. You had to use clues like negative or positive. You had to use clues like the vertex. HK. Number 36, let me give you a second. They gave you, did they give it to you in the nice factored form? Did it start like that? Nice. You didn't even have to complete the square on that one. Chris, go ahead.
Is this 2.2?
Yeah. Parabolas?
I don't have the same stuff on my paper.
Are your numbers different?
Are you calling 9 to 14 all? 15, 19?
Has anybody started writing down?
Yeah, that's right.
Yeah.
Wait, okay, 10?
So 10 is just matching.
Oh, okay, we're good. We're understanding. We're good.
So B, and then F, and then C. Poor guy. He was like, ah! All right, we're good. Here we go. Come back. Number 36. That's okay. You're checking the vertex. Did you figure out HK? You're checking the focus. Did you? Ooh. Okay, their work was kind of weird. But hopefully you guys were able to figure out that you could set 4P equal to, was it -1?
Yeah.
I think it was -1. And when you solved for P, you ended up with -1/4, and that's what they used. That's how they got the focus. -25, no, -20/4 minus 1 is -21/4. So it went just a little bit to the focus. They didn't show it. Well, it's there. A little bit to the focus, a little bit to the directrix. That one was really weird and awkward, but there you go. Focus and then directrix. What's our next even? Why they give you so many odds? To be able to check and work through what you're confused on, so you can now ask me questions. Any questions on the odds? You guys have already done them and checked them. Jackie. Okay, 57, 59. Anything else besides 57 and 59? Chris.
Can we go through like 15?
Okay. Let's start on 15 then we'll go to the 50s. Anything in between? All right. So here we go, number 15. Why was it weird? It was very weird. Why was it weird? They gave you a random point. They didn't give you the vertex. They didn't give you that, well, the vertex I guess we know. But they didn't give us a focus, and they didn't give us an equation. So how are we supposed to deal with this guy? How are we supposed to deal with this guy if all we have, well, let's see what we do have. What standard form are we going to match it to? Remember the yellow box yesterday? I had you go find it. I had you highlight it, star it. The yellow box, there are 2 formulas for parabolas. Which one does this fit under? Good. Good. Are we doing okay with, let's get a standard form and then try to match. We're doing okay with that?
Yes.
Okay. And you're also studying them at the same time, which is good. So what can we plug in right away for our HK? Okay, because we see the vertex, right? 0, 0. So we're going to have x minus 0, quantity squared, equals 4p. Now, wouldn't we love to have the focus or the directrix and then measure how far in between to make our p? But we don't have the focus. We don't have the directrix. But what do we have? We have a point on the parabola that needs to, exactly, Jacob, be an x and a y of my function. So I'm not going to be plugging in the p. I'm going to be plugging in what they gave me, which was an x and a y. They didn't give me the traditional way to find p with a focus or directrix, but they did give me a way. A point is enough. So 3 squared is 9. 6 times 4 is 24. P is going to equal 9 over 24. 3 goes into both 3 and 8 times. What was the job, or what was your goal? Oh, just get an equation. So go back and plug it in. Right? end up with x squared, because x minus 0, 4 times 3/8. That'd be 12/8, or I can reduce to be 3 times y. I mean, you could write it a little bit nicer. Yeah. Yes. Yes. And then plug in that x, plug in that y. So we could have simplified. We could have simplified here and made it a lot prettier. X squared equals 4py, then plugged in. I just kind of, I don't know. I simplified later. Jackie, you said 57, 59? Okay. Let's go find. Oh, no. Well, that's going to be fun. Okay. 57. Well, here's the nice thing. We can still use my snipper. I'll just snip white space. Awkward. All right. I don't know why I just figured out that's a great way to do homework questions. This is snippet and then that's okay. Section 10.2. Learn something new every day. I don't know if that's necessarily true. 50. Did you guys see there are really cool pictures that I didn't make you do? Take a look at number 67. There was a fluid flow. There was a window design. There was an archway, suspension bridge. There's all sorts of cool stuff. But I narrowed down your homework so you didn't have to do everything. Okay, 57, 59. Which one, for those of you guys that did 57, 59, they're both the tangent line problem, and I would love to review it. I just don't know if we need to do two. Which one looks harder, 57 or 59? Maybe let's do the, I guess they're both kind of facing. Yeah, let's do 59 because he's not written in our standard form. So 59 gives us the problem of, I think I have to actually change it, don't I? There we go. Chris, you have it right there, right? What's my equation? Y equals?
Y equals negative 2x squared.
And the clue or the point they gave you?
Negative 1, negative 2.
Okay. To get it in our standard form, wouldn't we have to switch these two? Because we're going to make it match the x minus h quantity squared equals 4py minus k. Is that okay?
Yes.
Why am I doing this one even though the y comes first? It's all about the squared. Good. So then with the squared, I can make this match. Let's see if you guys can follow. Can you follow two steps at once? What'd I do? Good. I divided both by negative 2. And then I took the x squared to be on the left. And I took the negative 1/2 y to be on the right. And I wrote my 0, 0 because there's no addition, subtraction, no vertex other than the origin. Why was I doing all that? Well, now I can graph it. I know it was, ooh, which way is it facing, guys? It's at the origin. It's going down. Negative coefficient, good. So tangent line, what's the point I'm supposed to be doing? Oh, negative 1, negative 2. This needs to be a whole lot narrower to get that done. Let's try again. Negative 1, negative 2. Okay, so it must be a lot narrower than I thought. Okay, I want a tangent line. Sweet, tangent line. If I were you to open up your notes, we're going there in about 30 seconds anyway for section 10.3. Go find me the tangent line stuff from yesterday because it takes some work to get used to this one. If I want a tangent line, what equation of a line am I going to use? Yeah, y minus, y minus, I have a y1, it's negative 2, so y minus y1, y plus 2, equals m times x minus x1. Do you guys see how I just plugged in my point? It's a point slope form. I have a point, good. I need a, yep, how do I find m? Rise over run. But the problem is, all I have is the minus y2 and the minus y1 part. What do I still need? My other point. My other point. Does anyone remember where I can get another point on the line that skims the graph here? I can't get any other points from the parabola. I know it looks super close, but it's technically, as soon as it passes this point, it gets a little bit off, a little bit off, a little bit off, a little bit off. Actually, a lot more off, a lot more off. It only skims, like a tangent line in geometry to a circle, only hits at one point. So I can't steal any other points from the parabola, but I can steal a point from... What's so special about this guy? Equal distance between the focus. So I need the focus. I need the focus. I can't do anything else until I find my focus. But that's okay. We've been practicing that. So I find the focus. Why am I circling the negative 1/2? Because that's how I find p. Careful. So I can say 4p is equal to negative 1/2. Divide by 4, divide by 4. P is equal to negative 1/8. Well, does my line look like negative 1/8? Doesn't look very much like negative 1/8. Well, hold on, wait a minute. But the line isn't the focus. Where's the focus in this parabola? Down. So here's the focus. I didn't down and then...
Yeah,
Oh, really? Did it sound like that? I'm so sorry.
No, it's cool.
Down and then... That would be such a pointless use of that word. Down. So, question. What's the point? What's the point? Well, we went down. How far? Yeah, so I'm going to have, this vertex equals 0. X stays the same, yeah? Remember, it's helpful if you can follow. But if worst comes to worst, it's h, k plus p. If you want to memorize it. It's h comma k plus p whenever you have a downwards facing or upwards facing parabola. So why am I making a big deal about this not being 1/8? The directrix is 1/8. But not that. That's different. That doesn't hit the directrix. It's in the direction of the directrix. Josh, hood off. Too much temptation. I think you're falling asleep back there. So, coming back. Guys, this is not the distance between the focus and the vertex. This is the distance between the focus and the... We have to find D. Remember from yesterday? Look at your notes. We got to find the D. How do we find the D? Old-fashioned distance formula. D is equal to the square root. Distance between who and who? Distance between, good. The x1, y1, which is our point, negative 1, negative 2, and our focus. The distance between the focus and the point. You guys see it in your notes? D?
Yes.
All right. So y2, I don't know, I'll use that guy. x2 minus, which will be a plus, x1 squared, minus, which will be a plus. 1 squared is just 1. That's easy. What am I going to do? You guys know me by now. What am I going to do to put these fractions together? Make this guy 16/8 times 8 over 8. 16/8. And what's 16/8 minus 1/8? 15/8. 15/8, squared? Good, me too. Because 15/8 squared is going to be the same thing as 225. Someone double check me. 64ths? And then this one, what am I going to make the 1? You know me. 64 over 64, and 64 plus 225 is going to end up being 289. And 289 is the square of? 17/8. 17/8. We're in math class. It's okay that we're doing numbers. Okay, so anyway, coming back. You guys are freaking out a bit, but still, it's okay. 17/8. Who is it? Isn't 17/8 this distance? Where else can I see D? Look at your picture. D goes from the focus to the point on the parabola, but it also goes from the focus to the missing point I want. So if I need to move, I just found 17/8. If I need to move 17/8, what's my new point going to be that I'm going to come over here and plug in and finish my problem with? I was thinking a 0 for the x. Oh, so looking at the y value. Okay, so for my second point, I'm moving from 0, -1/8. I'm going up. It's going to be basically h, and then it's going to be, well, I guess it was k plus p, and then plus 17/8. So what's -1/8 plus 17/8? Good. Oh, a nice little pretty point, even though we had yucky like 225 and 289 and all this crazy stuff. Bah ha ha. So what's my y2? 2. My y1 is minus -2, hence the plus 2, right? My x2, 0. My x1, minus -1, plus 1. So what's my m going to be? 4 over 1 is 4. Ha! So what's my tangent line? Y plus 2 equals 4 times x plus 1. Could you make it pretty like the book would and put it in slope-intercept? Y equals 4x plus 4 minus 2. Y equals 4x plus 2. Yeah, you could. Dun, 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 dun. So, now that our rhythm is awful. What was the process? Real fast, one last time. Tangent lines. Get a graph. Graph the point. Skim. How many points do we need for a tangent line? Well, we plug in 1, but then for the slope, how many do we need? All right. So we have 1. Where do we go looking for the other one? We want the D to move from the, wait, who do we not have yet? So we found the focus using all of our clues. Once we had the focus, we were able to find our, once we found D, we were able to move up D, find our point and say, psh, dun, 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 after plugging in. So, sketch it. Focus. Distance. New point gets plugged in. Graph it, focus, distance. Move. New point gets plugged in. All right, Jackie, does that kind of help you think? Cool. Let me get rid of this because we're digressing quite quickly. Let me get rid of that. And let's go to section 10.3. Hey, Mr. Strike just in math. I like it. Here we go. Your sitar? You have a sitar? Oh, I was like, wow. Ovalness, not Ovaltine. Ovalness, the ellipticity, I don't know, I'm just making up words now. How elliptical, how distorted the ellipse is, how non-circular. Anyway, that's why they made up a word. Not made up, we'll say it was very technical and not made up. Anyway, eccentricity. So that's what the idea is of this picture, how we get an ellipse. Think of a suspended string being extended with, for instance, like a marker, kind of like a compass, but a little bit more complicated. And then you can go ahead and go around and form the ellipse. So the farther the foci are from each other, the more elliptical, and the closer they are, the more circular. But I want to show you something with the circle, standard form of a circle. We could take this circle real quick, and we could divide everything by r squared. What would happen if I divided everything by r squared? Just rearranging a little bit. What's r squared over r squared? 1. And what does this look like? Those. But what's different? Instead of having two different measurements, what do you have? The same. So technically, every circle is an ellipse, a special ellipse where a equals b, or where the coefficients are the same. Let's zoom in on this yellow box and try to get a little bit more experience with what all the important pieces are on this page. Okay, yellow box, highlight it, star it, frozen notebook, go team. Whoa. Blue circle of death. Even better. Okay, whiteboard. Don't worry, I've had worse. It's been a while. Is it working? No. All right. Guys, what's the first equation that you see? Does A come first in the denominator or does B? Huh. Okay, so A comes first. Good timing. The Lord just wanted you guys to have a quick breath. So there you go. Quick breath. Here we go. Couple things. Center. However it's written, is going to be HK. The center, however it's written, is going to be HK. So you can see the center in both, whether it's horizontally oriented, the major axis is horizontal, the longer, major, longer, minor, shorter axis is horizontal, or the major axis is vertical. If you notice horizontal, if it's longer horizontally, where's the A under? The A is under the X. If it's vertically oriented, where's the A under? Ooh, maybe there's a way of studying that. Who is A and who is B? Let me show you. A is the distance from the center to the vertex. Think of it like a radius. Think of it like a radius. So we could call A the major radius. So what do you think B is? The minor radius. Now the axis is the whole length. The axis is the whole length, but the radii themselves come from square rooting the denominators. So the center is HK, the major radius is A, how far out to go, and if it's underneath the X, it's how far right to go and how far left to go. If B is underneath the Y, then it's how far up to go and how far down to go. So the nice thing is that the formulas really are super similar. You have HK in both of them. You have both of them being squared in both of them with an addition. There's no craziness of needing to worry about the order or the side of the equation. The only thing that changes is who has A and who has B. But if you guys notice it, all that changes in this picture is now the horizontal is B and the vertical is A. Like, well, that's confusing knowing which one's which, but pause. Who's underneath the X? Yeah, so that makes sense maybe why B would be the horizontal measurement, and who's underneath the Y? So maybe it makes sense why A is the vertical measurement. So you always get to steal the square root of the denominator and use it for that extension from the center, whether it's horizontal under the X or vertical under the Y. So technically, we still have a major radius of A on this one. He's just going a different direction now. And we still have a minor radius of B. He's just going a different direction. But that's as seen by where these variables are found. Now hold on. There was some other important part that we talked about. Oh, vertices. Vertices. For this one, we could say to get to the vertices, we're going to go ahead and, let's put that over here. We need to move horizontally, which means we're adding to the X's or the Y's. Good. So we're going to have H plus or minus A, K, because we need H to go over A with the same K or H to go back A with the same K to get to the vertices. What's going to change on this one? Careful, not H. Because I need the Y's to go to the vertices, because it's only on the edges of the major axis, so it'll be K plus or minus A. Now technically there's only one missing. You wouldn't know they're missing unless you knew that they were there in the first place. They're kind of like parabolas, right? Kind of like a vertex with parabolas that are facing in on each other. They're actually not, because parabolas would kind of come to a point instead of coming to a nice rounded off. Foci. Yeah. We just talked about the foci a second ago, but we haven't even written anything about it. And let me tell you who the foci are so you can have it in your nice yellow box, but then we'll have to go talk about, because there's no P in this equation, so that must not be how we find it. But let me show you what we are going to need to find. Foci are going to still be like the vertices coming out from the center along the main axis, but you guys saw it doesn't go all the way to the vertices. I have H plus or minus C. Who's that guy? And down here, if it's oriented differently, it's going to be k plus or minus c. Who's that guy? C? Kind of. Kind of A and B together. Now, A and B, you guys see a little right angle, right? So maybe you could think of making a little Pythagorean with an A and a B and a C. The struggle is this C measurement going to help me with the foci? No, it's going to be too long because the hypotenuse is the longest side of a triangle. So I can't do A squared plus B squared is C squared. But I can do the following. Oops, we already did that. That was just visualization. We can't do A squared plus B squared because that would be too long. That would take us outside of the ellipse. But I need still that relationship to be somewhat present. It's not Pythagorean theorem. It's not. There's a minus. There's not a plus. It's not Pythagorean theorem. But you can kind of use Pythagorean to study it and to remember it. So if you, or when you, have the A and have the B, if you use this formula, you will be able to find the C. And the C is going to allow you to go from the center to the focus, and what we do on one direction or in one direction, we have to do in the other direction as well. So we're going to go plus C and minus C to get to the foci. Now here's the weird thing. This shape, I don't know how I got ship. This shape is pretty elliptical, right guys? And didn't we see if it's pretty elliptical, those foci should be pretty far apart? So maybe I'll go ahead and, just for sake of argument, make those foci a little bit farther apart, because this is pretty stinking elliptical. So then we'll make this be our C. There we go. We can go back to the other foci. I apologize, the other focus. So we're going to take A, we're going to take B, we're going to plug it into our formula, and just think of this. C is always a positive. Sometimes we add it, sometimes we subtract it, but it'll always be a positive. So you want the number minus the smaller number, the square of A minus the square of B. And it's going to work no matter how the ellipse is oriented. Because however you go, when you do C squared equals, ooh, wait, A is the longer one. Poor little A. There it is. B is the shorter one. No matter how you solve it, it's up to you to get it oriented the right direction and to move C the right way on the major axis. But as long as you move it on the right way, you'll have the two foci. So you can take an ellipse and you can figure out where their foci were that would have formed the shape if you had needed to move it. Interesting. I wonder if that's how a 3D printer makes elliptical objects. Because you can't use a compass to make elliptical objects, right? You can't use a blade that goes in a circle. I wonder if a 3D printer, have you guys ever seen them? They're really cool. I wonder if it uses the idea of foci to make the ellipse. Interesting. Find the standard form. It might not. I honestly don't know, but it could be in the programming. Find the standard form of the equation of the ellipse with the given characteristics in the center at the origin. Ugh. Hey. Origin. Question. What did we do with parabolas at the very beginning of any problem? Try to match it with? Good. So which standard form would this one go with? Look at your pictures. Look at your pictures.
X minus H squared.
Yeah.
Yes.
Yeah, because it's horizontally oriented, right? So x minus h squared all over a squared plus y minus k squared all over b squared equals 1. Once you get a feel for it, it'll go faster because ellipses are actually kind of easier than parabolas because all you have to do to really make this is to ask yourself, well, A, where's the center? I can make HK. And when I go to plug into the denominators, you can just remember everybody's squared, like literally. You can remember 1 squared if you want, because 1 squared is always 1. Anyway, I plug in HK. Then I just have to ask myself, hey, who goes underneath the x1? Well, horizontally. What's the distance horizontally to get to the edge? 2. Sweet. Plug in a 2. Under the y1. Come on. 3 over 2 is how far? Huh. Dun, 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 dun. Okay, make it pretty. Make it pretty. So x minus 0 is x squared. I'm not finishing it because technically we're not done yet. All over 4 plus y squared all over, ew. Do you think they'd leave it like that with divided by 9/4? No. But see if you can make the jump they would in the answer key. Dividing by a fraction is multiplying by its reciprocal. Joel, hang in there. We're almost done. Dividing by a fraction is multiplying by the reciprocal. How bad was that? Found the center, HK. For underneath the x, we'll go look at the horizontal distance. For the y, go look at the vertical distance. Do they ask us anything else? Find the standard form. Done. Okay, that's not bad, right? So let's go do another one. You guys okay if I change the screen? Okay. Find the standard form of the ellipse having, ooh, they just gave us foci. They just gave us what we needed to make the shape. Interesting. I just covered everything up though. Let's go back. Let's go forward. When I try, and it doesn't work. Okay, full screen. Foci. Center. If you guys get a feel for it, maybe pretty soon you could realize on this guy you don't really have to even fill in too many things because both forms have us with an x minus with a squared, a y minus with a squared, and 2 denominators with squares. Don't even really have to think about which one's which, to be honest. But as you guys look at this picture, is there anything we can plug in? We still have time. Yeah, who is the center? Okay. Now what? How far over? How far up? How far over? Okay, well how far is the focus? So I know that C is equal to 2. Well, stink, I have a formula. It's a good formula and all. C squared is equal to A squared minus B squared. But does it help if I know that C is 2? I still am missing A and B, right? Pause. Did they give us anything else? So from beginning to end is 6. If that's 6, then what would my A be?
3.
Nice. And who's that going to go under? Because it's horizontal. So X. So I know my, I know my A is 3 and my B is who I'm trying to find. So couldn't I do 4 minus 9, which is negative 5, divided by B is equal to the square root of 5. So then pretty quickly you end up with, let me finish this one and box it. A root times a root is a non-radical. Start homework. Guys, we basically have the whole section, but maybe you'll get a little confused at the end. I'll take homework questions tomorrow real fast. We'll grade on Thursday. We only have a little bit more 10-3 to do. We're going to 10-4 tomorrow.
For example, when you got